helpful when you're absent.
Yes. All right, what side would be opposite of angle A? What side would be opposite of angle A? Let's see, some people we don't hear from. Jeremiah, what side would be opposite of angle A? Segment BC, very good. And the side opposite of C? Lauren? Segment AB, very good. Kind of goes backwards. And then, ooh, the value of X. There's two ways you can find this. If you remember the one theorem we learned, it's a little bit faster than the others. Joseph? 105. Good, we should be getting 105. Okay, obviously you could find out what this angle is, 75, and then use a linear pair. But you also could use the triangle exterior angle theorem, which says the exterior angle equals the sum of the two remote interior angles. So this angle would have to equal the sum of those two angles. And that was a little bit faster, just 75 plus 30. Okay, but you also could have used triangle sum and then linear pair 2 steps. All right, so today we're looking at isosceles triangles and equilateral triangles. Do you remember the definition of an isosceles triangle? Good. The definition is that it has two congruent sides. Okay. So if you were doing a proof, which we don't do many proofs with these, but if you were, you could say the definition of isosceles triangle if you knew that you had two congruent sides. The isosceles triangle theorem says if two sides of a triangle are congruent, meaning that it is an isosceles triangle, then and I believe this will say base, angles opposite of those sides are congruent. So the angle that was opposite of the congruent sides. Okay, we do usually call these base angles. Base angles. This angle up here is usually called the vertex angle. So our little if-then statement would say, if segment AB is congruent to segment AC, then we know angle B has to be congruent to angle C. And I did introduce this concept to you when we learned isosceles triangles. We were doing some of those puzzle problems so that you would be able to do them. So this is the formal proof. And then our converse theorem, remember all that the converse does is it takes and switches the hypothesis and the conclusion. Okay, so the converse flips those around and says, if two base angles of a triangle are congruent, then the sides opposite of those angles are also congruent. So working in reverse. If you know you have two congruent angles, then the sides that are opposite of those have to also be congruent. So if you know one, you know the other. And vice versa. So if we know angle B is congruent to angle C, then segment AB must be congruent to segment AC. So a problem you might see could be something like this, a triangle that has markings, two congruent sides, and I give you one of the angles is 100 degrees. How could I find the other two angles? Or the measure of each of the other angles? Kate? Good. You can take triangle sum, which is 180, subtract the vertex angle to get 80, and then since the two base angles have to be congruent because of the isosceles triangle theorem, you can just divide that by 2. I don't require work for these. I think that you can do them either mentally or if you need a calculator, you can use that, but you should be able to do these without a calculator. You also could do it algebraically. So if you wanted to, you could have put an x in each of those spots because we know that's an unknown value and we know this has to be the same unknown value. And then if you're an equation person, you can show work. X plus 100 equals 180 and then solve for x. Combine your like terms and so on. All right, the next theorem, we want to put a whole bunch of stars next to this one, draw attention to it. Because if you forget this theorem, there's a good chance there's quite a few questions on your quiz that you will have no idea how to solve. Okay. Memorize, memorize, memorize. Okay, and the theorem, we usually don't use it in a proof. It doesn't have a name, it just has a number. So if we were to ever use it in a proof for like a challenge problem, you would actually either write theorem 4-5, which you probably won't memorize, but you could write out what the theorem says. So it says the bisector of a vertex angle. So an angle bisector of the vertex angle, which is the top angle, of an isosceles triangle will be the perpendicular bisector of the base. So if you see an angle bisector that's going in the middle of the isosceles triangle at the vertex, what it does is it creates a perpendicular bisector. And if you remember, a perpendicular bisector does two things. What are those two things? Maddie?
Makes them go to 90 degrees.
Okay, two right angles. And?
It makes the two things together on the side of it.
Segments? Okay. Two right angles and two congruent segments. So as soon as you would see an angle bisector in an isosceles triangle, and that's at the vertex angle, you can insert right angles and congruent segments. Okay. Again, if you don't memorize this theorem, you will forget to put the 90-degree angles in, and that's really important for you to be able to find angle measurements in the triangle. And you'll see that on the back. So it says if AD, and that should have a segment bar, bisects angle BAC, then it will do two things. AD will be perpendicular to the base, which is BC. And AD will bisect BC. So it's a perpendicular and a segment bisector is basically what it is. But a perpendicular bisector, they just leave off the word perpendicular segment bisector. They just let it do the two things at once. Correct.
Where are you getting AD from the picture?
I have a handwritten D right here.
Oh, okay.
So let's put that on our picture. Thanks, Brett. On the back, I'm missing a ton of markings on your paper. So before we start any problems, we're going to have to add those in because they somehow didn't get on the paper before I copied it. All right. The last thing just talks about equilateral. And remember, equilateral triangles have three congruent sides. If something has three congruent sides, then it has to have three congruent angles, making it equiangular. And also, the converse of that is if it's equiangular, then it has to be equilateral as well. So they kind of go hand in hand. Now, an equilateral triangle is called equiangular. What would the measure of each of the angles have to be in any equilateral triangle? What would the degree measure always be?
Ms. Lasso, Mrs. Underwood, please report to the library conference room. Ms. Lasso, Ms. Underwood.
Right. Good. They're always 60 degrees. So if you see an equilateral triangle, the angles will always be 60 because 180 divided by 3 congruent angles, has to be 60 every single time. Triangle sum never changes. It's always 180. 180 divided by 3 is always 60. Okay. All right, so on the back, first of all, if you could add in the markings that you see on the board here, because your notes to have no markings on the triangles. So I'll give you guys a second. Anything you see in red and blue, add in those markings, otherwise we're going to have trouble solving. Okay. So in example 1, we're finding the value of x and of y. First of all, you should notice that we only have one given angle. Now there is something, is there somewhere I can copy and paste that angle to based on the picture? The 63? Marquise? Angle N. Using the isosceles triangle theorem, if we have two congruent sides, we have two congruent base angles, the angles that are across from them. But then you'll run into a problem because triangle sum you need to know two angles, and right now we only know one. Okay, so this is that problem that I was telling you we have to use our theorem 4-5, which says if you have an angle bisector of a vertex angle in an isosceles triangle, then this will become a perpendicular bisector to the base. So what we'll insert are two right angles and two congruent segments based on that theorem. This is the type of problem I'm saying if you don't memorize this theorem, you won't know how to solve it. Some of you will just put 90 because it kind of looks like 90 and then you might get it right anyways, but there's a reason why we put 90 there. Okay, so x is just 90 degrees. What would y have to be? Joseph? 27 is correct. And that's using triangle sum. So 180 minus 90 is 90. And then 90 minus 63 does get us 27. Okay, and technically both of these angles would be 27. Okay. Now the next one we have some markings we added in. Again, you always want to start with your isosceles triangles. So if I know that these two sides are congruent, then I know that the angles across from them also have to be congruent, the base angles of the isosceles triangle. So if this is 52, this is also 52. Sometimes you'll want to find angles that are not asked of you to help you find the ones that you do need. How can I find B then? How can I find B? Joseph? Good, we'll do triangle sum again. If you want to write an equation, 52 plus 52 plus B equals 180, or you can just take 180 and subtract 52 and 52, and we should get 76. So these are kind of like some of the puzzle problems we saw in the past. So what would angle C have to be? What would angle C have to be? Maddie? Good. We can use a linear pair again. Remember, linear pairs are two angles that are next to each other and form a straight line. They have to be supplementary by the linear pair theorem. So we did 180 minus 76 to get our 104. Okay, now how are we going to find out what A is? Joseph?
Under 76 is vertical,
Perfect. We at this point can use vertical angles to copy this number over here, because we know vertical angles are congruent. And then we can use triangle sum, or we can create an equation if you're an algebra person, copying A there. And we could write A plus 76 equals 180. Or, for those of you that prefer, you can take 180 minus 76 and just divide it by 2, which is the same thing as doing this. And we should get that A is 52. It's going to actually be the same as the other ones. Now, some students will say, Mrs. Bennett, couldn't I use alternate interior angles? Well, you could if we knew these were parallel, but we don't. So we can't, that's not the reason that they are the same. All right, see if you guys can try 3 and 4, and then we'll come back to, all right, who can tell me what they got for number 3, for A, B, and or C? Give me one of them, doesn't matter if you give me A, B, or C. Who thinks they could share one of their answers? Marquise? A is 116, how'd you find that?
By doing the 64 minus 4, 180 minus 64.
Good. Using your linear pair that we know together, these have to sum to be 180 because they're supplementary. And that gets us 116. Who can tell me what they got for B? Luke? 64. 64, how'd you find that?
Vertical angle.
Good. And what would C have to be, Maddie? C would have to be 58. Now the only reason that you know this is because if you were to notice that this is isosceles, therefore you could find out each of these was 58 by subtracting and dividing by 2. And then you notice that there are congruent markings to indicate that this one has to be congruent to this one. Technically then, this would also be 58 by triangle sum. We don't necessarily know this is isosceles at that point because it doesn't have the markings, but it would be. So C was 58. Very good. All right, so in number 4, we should add in the congruent sides and the congruent angle markings. Those should have been given to you. My apologies. So, what would X have to be? No? 90 degrees. Remember, if we have an angle bisector at the vertex in an isosceles triangle, it creates a perpendicular bisector with the base. So you should be inserting right angles and congruent markings. So X is 90. What's Y going to be then? What would Y be? Joseph?
45.
45 also. And that would be using triangle sum. This was our theorem 4-5. Again, that has to be memorized, otherwise you'll not know what to do. Okay, for this one we did triangle sum with 90 and 45. Not what else. All right, now in this one we see some algebra, right? So first of all, add in the markings if you didn't already. We have an isosceles triangle. Triangle ABC is isosceles. So what's something I could add in marking-wise to the picture? No?
2x plus 20 to angle C.
2x plus, is that a minus?
No, yeah, it's minus, sorry. 2x
Add this over here?
Yes.
Very good. We know if they have 2 congruent sides, then they also have 2 congruent base angles. If they're congruent, and this one's 2x minus 20, he kind of copied and pasted that over here. Now, how do you think I could solve for x? Should I set that equal to 8x? Brett?
So take both of them and add them together, or, yeah, set them equal to 180.
Good. You do not want to set these equal to each other. Okay, first of all, we shouldn't use our eye to judge, but one is obtuse and one is acute. Okay, they are not congruent, but they are a linear pair. Which a linear pair is supplementary. Therefore, they have to sum to 180. So you would have 2x minus 20 plus 8x equals 180. And then just solve for x. First, combining our like terms on the left, 8x and 2x is 10x. And I know you guys know how to solve, but some of you skip your steps and then somehow you like would subtract 20 instead of add 20. So just take your time. Would add 20 to both sides and then divide by 10. Should get x equals 20. If you wanted to, you could go ahead and plug those back in and find the angle measurements. Okay. Almost done. The second to last one, I do want you to change that to be 122. Otherwise, it doesn't make sense because it's an obtuse angle visually. Why don't you guys try 6 and 7 on your own? 7 doesn't need any additional marks. Joseph? 151. Very good. We should have taken 180 minus 122 and then divided that in half to get 29 degrees for each of the base angles. And then you have 2 options. You can use a linear pair, just what most people like, or you could actually use the exterior angle theorem, which is the sum of the 2 remote interior angles. Okay. And then how about this one? What did you guys get for x and what did you get for y? Maddie?
I got 3 for x.
Uh-huh.
55 for y.
Very good. So for this one, we have an isosceles triangle. If this is 50 degrees, this is also 50 degrees. And then triangle sum would yield that x is 80. And down here, we see that the base angles are the ones, again, across from the leg. So if this is y, this is y. So to get that easily, we would do 180 minus 70 to get 110. And then just divide that evenly into 2 congruent angles. Again, if you're more of an algebra person, set up an equation, y plus 7 equals 180, and then you would solve that. Okay, the rest of the time is yours to work on the homework.